Our first day, we have an insightful introduction to a cutting edge field. Please welcome Amira Best. Amira will be exploring agentic AI, discussing the core principle of AI systems capable of autonomous decision making, their potential applications across various industries, and the important ethical and safety challenges they present. So, Amira, you're welcome.
Thank you so much, Anna, for inviting me. It's a pleasure to be here and pleasure to be talking with you all today about exploring agentic AI. So my name is Amira Best, and I have to start with the standard disclaimer that the views expressed here are my own and do not represent my employer. So about me, excuse me. I'm a Women Take Makers ambassador. I hold a doctorate in computer science, and I've been working in AI across industries for over 15 years in academia, government industry, and across various industries. So I worked in biotech, pharma, in manufacturing, and the financial domain. So today we're going to talk about, we're going to start with the overview of agentic AI, and then we'll explore core principles of agentic AI. That how do we define them, discuss potential applications in fields such as robotics, healthcare, and finance. And then we'll talk about reinforcement learning, human alignment, we'll touch on Gemini, and these applications in various fields, as well as ethical and safety challenges. So, what is agentic AI? So, agentic AI is AI that can plan and execute using tools to achieve objectives like agents. So, the agents are capable of autonomy. They can make decisions without human intervention. They also perceive their environment through sensors and act upon that environment using actuators. They are designed to achieve specific goals and um, take actions based on their perception and their internal state. So it's really important for us to understand the principle behind these AI agents for accountability and transparency. Also, um, so like we said, the agents are capable of autonomy. They can operate um, um, autonomously, as well as they can improve the efficiency by continuously adapting to new data. This leads us to how do we evaluate these AI agents? So evaluation criteria for AI agents are critical to ensure their reliability and safety. There's different kinds of ways that we can evaluate these agents. So for instance, the accuracy is challenging in a lot of cases, especially because these tend to be built on generative AI, which produces non-quantitative outputs, and it's non-deterministic. So every time that you run it, you have a different answer. However, what's usually done in practice is we measure performance against predefined benchmarks. We also care about latency. And why does it matter? Because the latency refers to the time delay between an input prompt and getting the output response. And of course, lower latency is better from user experience point of view, but also it can make a difference between a safe or use or, for example, having an accident in robotics applications. So for also for financial applications, cost or the latency matters when we need timely data analysis for decision making. Cost metrics, so we can look at the cost per inference request, but also the infrastructure and the energy consumption needed to run AI agents is becoming increasingly important from an environmental perspective. So, so there are two primary approaches to agentic AI. We have augmentation versus automation. Augmentation refers to enhancement of human capabilities through AI systems. In this approach, AI serves to amplify human productivity while keeping human oversight to reduce risk of errors and unintended consequences. The automation involves delegation of tasks to AI agents, minimizing or eliminating the need for human involvement. This can lead to increased efficiency and cost reduction by reducing the need for human labor. However, there are ethical concerns due to limited human oversight, security risks, and so on, which we'll talk about later. So this slide is actually comes from Anthropic, where they looked at the number of prompts that came from um, users and looked at what's the percentage that's actually related to augmentation versus automation. So what you can see here is the majority of prompts coming to Claude come from augmentation. So now we're going to talk about agent architecture. So the architecture of a general AI agent involves several critical components. So we have the orchestration, which is really important. We have the models and the tools that all work in concert to enable the agent's functionality. The orchestration refers to the piece that does the coordination and the management of the components and processes and ensures that data flows between different modules and that the agent operates efficiently. So what does this include? So for instance, you could have as orchestration a supervisor agent that would route to worker agents um, different work that needs to be done for improved efficiency and effectiveness. So this is very useful, for instance, in let's say task scheduling, data management, data preprocessing, computational resource allocation, monitoring, logging of to collect metrics, right? To facilitate debugging, maintenance, and overall system improvement. So we have kind of two um, different ways that we can use these two different frameworks that are behind these agents. So one is called Reason and Act, or REACT, which guides reasoning and action for user queries, improving the human um, interoperability. How does it do that? So it prompts the LLMs to generate not only verbal reasoning, but also actionable steps. So it enhances the dynamic problem solving capabilities of the model. And React so the other approach is COT, chain of thought, or for short COT. This enables reasoning through intermediate steps by breaking down complex tasks into simpler intermediate steps and guide the model through a sequence of logical steps to arrive at the final answer. So let's look more at the React. So we already, we said that let's say we want to do this, let's look at this real life example of a React application. We want to look for flights from Austin to Zurich. And so instead of the model coming up with the flight based on its prior knowledge, with the AI agent, you could use a tool called Flights that will search for real-time external information. This information is provided to the model, and it allows it to make a more informed based decision on factual data. And what about the chain of thought that we talked about? So this is an example of chain of thought for planning. So let's say you have a reflection actor is part of a self-reflective agent system where the agent, the actor in this case, critiques its own response to improve the output quality. So in this framework, the agent generates a response and then explicitly reflects on it by evaluating its own content, identifying missing or extraneous elements, and grounding the feedback in external data. So the reflection process involves two components. You have a responder and a reviser. The responder produces the initial response, right? And then this response is going to be critiqued by the reviser. Is going to critique the response and goes into a feedback loop using tools or external resources. And then this iterative loop can help refine the responses and leading to higher quality of the answers over multiple iterations. And the process stops after a predefined number of steps or when a satisfactory result is achieved. So now we talk about, in the agent architecture, we talk about the models, which are typically the models that are behind at the core of the AI agents are foundational models such as LLMs, large language models. They're often used in agentic AI systems. The model typically lacks the ability to directly perceive and influence the real world. So that's why we need the tools, right? So we'll get to the tools later. Right now, let's talk about some of the models that are underlying these, under the hood of these agents. So LLMs. So this is a slide that comes from Gwendoline Stripling, who is also a Women Tech Makers ambassador. And what is showing is that these LLMs are built from data. Gen AI can create content, right? So we know that it can create texts, images, audio, video. In this case, let's look at creating text. So it will look at the previous text that comes in and then predicts, like transform into the vector representation of that text, and then predicts the next most likely word. So in this case, the cat sat on, and then the next word is the mat, right? The cat sat on the mat. So the main idea that how this behind these LLMs is transformers. So transformers, they work by paying attention to different parts of the input. The analogy is, imagine that you are reading a book. As you read each sentence, you don't just focus on the individual words, but you use the context from previous sentences to understand a new sentence. So the transformers provide a way of paying attention to which words are most important to understand the meaning. The attention mechanism helps capture context better than other models, with layers each building upon the previous one. So how are LLMs trained? They're trained in the same way that deep networks are trained, calculating loss, backdrop, updating weights, and optimizing hyperparameters. Okay, so in some considerations for LLMs, so in um, one thing to think about is the memory. So let's say in this case, I have memory window of 1. So then it will only remember the last part of the conversation. So I said hi to the LLM. He says, hello, Amira, nice to meet you. My name is AI. I said, what's 1 plus 1? Says 2. And then I said, what's my name? And it already forgot because the memory was 1. But what you can do is you can, of course, have a larger window, and then it will work fine. By the way, as a side note, you would have for a typical book would be about 100,000 tokens in length, which fits comfortably in the context window of a GPT-4o1 model, for instance. So now, how do you prompt this model actually makes a difference. Lots of people working on this kind of prompt engineering. So there's one way that you can just literally just ask the question in at one time. It's called zero-shot prompting. You provide a single command, so it's typically something that you similarly do in a Google search, right? One-shot prompting is you provide an example of a task to the LLM, and then that helps it provide a better answer. Few-shot prompting is you provide a few examples of the task to the LLM. Other kind of thing that you can do is also use personas. So you can say, as a, prolific science fiction writer, right? This paragraph or something like that. So, okay, at the heart of AI agents is the concept of reinforcement learning, where the agent learns to make decisions by interacting with the environment. So the agent takes action, receives feedback in the form of rewards, and then this feedback is adjusts the state, or the agent adjusts its behavior to in the form of using this feedback that comes in the form of rewards or penalty to maximize the cumulative rewards over time. So the process involves exploration, where the uh, agent tries new action, and exploitation, where it repeats actions that yield the best results. So reinforcement learning is used when for tasks where the solution is not known up front and requires the agent to learn from experience, such as playing games or robotic control, etc. Let's take as an example an AI agent that's writing a paper, and it's gonna, follow a structured process, right? It's gonna do some research, write an outline, generate some text, and then revise it. So let's say in the research phase, we will maybe ask our AI agent to gather relevant information from various sources like academic papers, books, databases, reliable online resources. The agent might use APIs or web scraping tools to access these external databases or publications. The research helps the AI to understand the topic, identify gaps, and form a solid knowledge base for the paper. Now, after we have done our research phase, now we're going to start the outline. After gathering enough information, We write the outline, including organizing the key points and structuring the content in a logical flow. The outline typically follows a conventional academic structure using, let's say, introduction, literature review, methodology, results, discussion, and conclusion. The agent will then ensure that each section not only addresses important aspects of the topic, but also connects logically with the next, providing a roadmap for the rest of the paper. The next step is the generation step. So in this step, the AI can use the outline that we've done in the previous step to start writing the paper. So using the information from the research phase can begin writing sentences or paragraphs for each section. And then, yeah, like using a persona, we can prompt the LLM like as a formal academic, write the following sections and cite your sources. Once the paper is written, the AI agent goes into the revision phase, where the agent can critique its work. So the agent evaluates the generated content for clarity, checks for inconsistencies, redundant phrases, and unclear arguments. Essentially, the AI can refine the text and ensure factual accuracy, and that the resulting paper is logically structured and well organized. So human alignment. So this is a slide on the human, like reinforcement learning with human feedback, RLHF. Sorry, there's a lot of acronyms in this field. So it involves designing AI systems that align with human values and ethics, but learning from human preferences. So RLHF allows AI to optimize its behavior by receiving feedback, like we said, rewards or penalties from human evaluators based on its action. This feedback loop helps AI models understand what is valued by humans, allowing them to improve decisions and actions to better reflect aspects that are important to humans, such as helpfulness, fairness, and so on. So stepping back now to the general AI agent architecture, we talked about the orchestration and the model. The next piece we're going to talk about is the tools. As we were talking about when we were talking about the React flight example, where we have, for example, the tools that create a link between our foundational model and the outside world to find out what are the flights that are available. So there's three different types of tools. There's functions, extensions, and data stores. Functions are reusable modules that consist of predefined algorithms that allow the agent to process data, make decisions, and perform specific actions. For data processing, the function could do, let's say, feature extraction, data augmentation, and so on. For decision making, you could imagine that the function could have some sort of optimization algorithm inside it to make an informed decision. For action functions, these could be performing actions such as sending an email or controlling a robotic arm. Now, extensions, on the other hand, allow agents to connect with external APIs. So let's say we want to retrieve real-time data, perform actions on third-party platform, for instance, book a flight from our previous example, and so on. Now, the third type, as we said, of tools is data stores. Data stores let us access up-to-date data. So why do we need that? The LLM is limited in terms of it has been trained on vast amounts of data, but that data is static. So sometimes we need data stores to address this limitation by providing us access to more dynamic and up-to-date information. These data stores are essential for managing the data that an AI agent needs to operate for both structured and unstructured data. This is particularly useful in RAG application, retrieval augmented generation applications. And these applications essentially extend the depth and breadth of a model's knowledge beyond the foundational training data by giving the model access to data in various formats. Could be website content, could be structured data like PDF, Word documents, CSV, spreadsheets, etc. Could be unstructured data like HTML, again, and so on. So RAG is a technique that to enhance the AI agent's ability to generate relevant responses by incorporating external knowledge. So let's say that you want to create a tool that facilitates, let's say, Q&A in your organization, right? And this Q&A, like the information that you would need as an input to those Q&As are not available in the external world. So they would be sort of private to your organization. So what you could do is you could take this information, generate embeddings, and generate a vector database. So then when the user enters their query, the AI agent could process that query, transform it into an embedding, and then go check in the vector database to query what is the most relevant matches through similarity search, such as cosine similarity to my user's prompt. And then the relevant data could be brought back to the AI agent so that it has a better data to improve response generation. With augmented information, the AI agent can generate a final high quality response to the user's query by synthesizing the original query and the retrieved content. So we talk about RAG. How about targeted learning? So targeted learning in AI, particularly for large language models, involves strategies like in-context learning, retrieval-based in-context learning, and then fine-tuning. For in-context learning, this method allows models to learn from the immediate context of a query or a task. The model uses examples provided within the input prompt to understand the task and generate appropriate responses. It doesn't require retraining the model, but adapts based on the context. For retrieval-based in-context learning, this builds on in-context learning by retrieving relevant information from external sources, such as database documents, to improve the model's response. This method enables models access to up-to-date and specific knowledge without retraining. So this would be the example that we said about the Q&A, but it could be like a retrieval-based in-context learning using your organization's data. How about fine-tuning? Well, fine-tuning adapts a pre-trained LLM to specific tasks, enhancing its ability to generate targeted response. So in this case, this involves adjusting model parameters using task-specific data, improving the model's performance in particular applications. So next is a little bit about Gemini. So Gemini is a family of advanced AI models developed by Google DeepMind, and it's combining cutting-edge techniques like LLMs to handle a wide range of tasks, such as answering questions, generating texts, and performing complex reasoning. So Gemini is multimodal. It can produce text, images, video. It's also very efficient because its architecture is based on TPUs, so it enables parallelism. And it's very useful for compatibility because you can access Google Workspace, like you can imagine your Google Docs, Sheets, and slides, and so on, Google Cloud in general. So there's also very useful APIs for developers. So if you want to check it out and get some hands-on experience, I recommend to go to the Google AI Studio and look at the Gemini Cookbook. And it has already code for agents. Like you could have customizable AI agents, you can have pre-trained agents and multi-agent systems, which is a hot topic at the moment. So let's talk about potential applications of agentic AI. So like we said, we could enhance business efficiency, like streamline and automate routine tasks. Let's say for a healthcare application, we could imagine assisting in diagnostics, patient monitoring. For financial sector, we could imagine that we could use this for fraud detection and managing risks and improving customer experience. So let's talk about the robotic application. So let's say we have an autonomous delivery robot and we want it to navigate a warehouse, pick up items, and deliver them to specific locations in the warehouse. Say our robot is equipped with sensors like cameras, LiDAR, and so on. First, it can perform sensor fusion and create a map of the warehouse to be able to localize itself. The next step is path planning and obstacle avoidance. In real time, the AI agent must dynamically adjust its path to avoid unexpected obstacles that are identified using object recognition algorithms like convolutional neural networks, CNNs. And typically, reinforcement learning is used as the robot learns from its environment by receiving feedback on its actions. For example, rewards for successful navigation or penalties for collisions. So we mentioned some healthcare applications in diagnostics. So could be AI in like we could do track health metrics in real time. We could do drug discovery. So let's say we want to come up with an example of a healthcare application in diagnostics. We have an AI agent that collects clinical data, could be from electronic health records, lab results, and so on. AI agents can extract meaningful information from structured and unstructured data in these records to aid diagnosis. Then we could use medical imaging. Let's say the AI agent will process images, MRIs, CT scans, and so on. And the image data is often analyzed using CNNs as well. For genomic data, AI agents can also work with genomic data such as DNA sequences, RNA data, and other molecular level information. The next step would be an agent to identify the risk of, say, cancer by combining all this information. After that, an AI agent for clinical decision support system could provide or suggest potential diagnosis for healthcare professionals and provide evidence-based recommendations for treatment. So in the financial domain, let's imagine we could have AI agent for fraud detection. An AI agent could first collect transactional data, such as bank transfers, wire transfers, online payments. This can be augmented by external data, let's say block lists of non-fraudsters or geolocation information and so on. Another AI agent could do feature extraction to get frequency of transactions and also an anomaly detection agent to analyze patterns in time series data and identify spikes or anomalies. Another AI agent could analyze the geolocation data to look for inconsistencies, such as, let's say, transaction in multiple distant locations within a short period of time. All this information can be used to identify the risk of fraud and generate alerts for further investigation. So while agentic AI presents significant opportunities, it also raises important challenges that must be addressed. So there's ethical considerations and safety concerns that are paramount as these systems become more integrated into society. The ethical challenges that are raised by agentic AI include privacy, bias, lack of transparency, hallucinations, and we'll talk about these a little bit more. So privacy, when we talk about data collection and usage, um, these agentic AI systems require large amounts of data to operate effectively. These data could include personal, sensitive, or confidential information. The collection of such data raises privacy concerns, especially if the data is not adequately protected or if users are not aware how their data is being utilized. So we need informed consent. We need users to understand and consent how their data is being collected and processed. AI systems that operate without proper consent or transparency may violate even privacy laws. We talk more about bias in the next slide, but briefly, LLMs may be trained from knowledge that comes from the internet, Wikipedia, blogs, and so on, that could have inherent bias in them and potentially reproduce historic biases that are present in the data. Lack of transparency. We need explainable AI. So many layers, so many weights in these AI systems, particularly these large LLMs, operate as black boxes, meaning their decision-making processes are not easily understood or interpretable. This lack of transparency makes it difficult for users and stakeholders to trust or challenge the AI's decisions. And then hallucinations, of course, yeah, let's talk more about the bias first. So AI agents are, like we said, they're trained on data, and if the data reflects these societal biases, for example, protected attributes such as race, gender, and so on, the AI can perpetuate and even amplify these biases in the decision making. And this can lead to discriminatory outcomes in areas like hiring or lending or healthcare and so on. So let's talk about the hallucinations. So AI agents, particularly those that use LLMs, can sometimes hallucinate, or what does it mean? To generate incorrect, misleading, or potentially entirely fabricated misinformation that appears plausible. So, what are the reasons for that? So, you could have, for instance, insufficient or noisy training data. If the training data is sparse, incomplete, or noisy, it contains, let's say, irrelevant or incorrect information, the AI model may struggle to learn accurate patterns, leading to hallucinations. For instance, the model might generate plausible sounding but false information because it lacks the proper data examples. Incorrect assumptions made by the model. So the AI models often make assumptions based on patterns they have learned from the data. If these assumptions are flawed, then the model can create answers that don't align with reality. So, for example, model might assume that all people in a specific group share the same characteristics and generate false conclusions based on that assumption. Biases in the data to use to train the model could be skewed or unrepresentative data. So if the data, let's say, contains biases or it's unbalanced, the AI model might produce hallucinated response to reflect these biases. Lack of context. AI models, especially those based on sequence prediction, might generate information without having full context. If a model doesn't have previous parts of the conversation, it may generate answers that are entirely inaccurate. Or lack of constraints. If the model isn't constrained by rules or factual boundaries, it might fill in the gaps with sort of inaccurate or fabricated context. So without proper context constraints like factual grounding, for example, cite your sources, right? The model can generate hallucinations that sound reasonable but are incorrect. What about the safety concerns? So safety is a critical concern for agentic AI. Ensuring that these systems operate reliably and do not cause unintended harm is crucial. Here are some security recommendations. So first, limiting permissions of the AI system, ensuring it only has access to data and resources that are necessary for its specific tasks. Um, this reduces the risk of unauthorized actions or data misuse. Sandboxing involves running AI models in a controlled and isolated environment where they cannot interact with critical systems or sensitive data. This approach helps contain any potential failures or malicious actions and preventing them from affecting broader operations. We can also anticipate potential misuse. So you say, this agentic AI system could be misused for harmful purposes, for instance, deepfakes or fraud, right? Prompt injection. So prompt injection are a form of attack where an external actor manipulates a prompt that can be injected, and so that it executes some code. And for example, a malicious user could craft a prompt that caused the AI to produce misleading or harmful response. So agentic AI systems can make decisions that directly impact individuals and society. And so these systems must be reliable and robust, especially in high stakes environments such as healthcare and finance, where incorrect decisions or malfunctioning models could lead to severe consequences, including financial losses or harm to patients in healthcare. So, in conclusion, I think agentic AI represents a transformative advancement in AI, and it has the potential to revolutionize various industries. However, it is essential to navigate the ethical and safety challenges associated with its deployment to ensure beneficial outcomes for society. And thank you. Are there any questions?
Well, hi.